Hey everyone, and welcome to this explainer. Today, we are going on a totally fascinating journey into the architecture of digitized knowledge. We're literally doing a complete mechanical teardown of how we take human expertise, years of study, gut intuition, and endless practice, and somehow translate all of that into pure executable code. Let's get right into it.
So, think about this for just a second. What if you could take a world-class doctor or, say, a master geologist and put their brain straight inside a computer? Imagine having that exact level of specialized, elite brain power sitting on a server somewhere, totally ready to solve incredibly complex problems for you at literally any hour of the day or night without ever needing a coffee break or a full night's sleep. That immense value, that's exactly what we're unpacking today. We're calling this whole concept the glass box. Way too often we tend to look at advanced computer systems as these mysterious black boxes, like data goes in, magic answers come out, and nobody really has a clue what's happening in the middle. But today, we're making that box completely transparent. We are going to peer directly inside the machine to really understand the architecture, the logic, and yes, definitely the limitations of how a machine actually mimics a human expert. Okay, so here's our blueprint for how we're going to break this down today. First, specialists in a box. 2, anatomy of a decision. 3, the logic funnel. 4, building the machine. And finally, number 5, the reality check.
All right, let's dive into section 1, specialists in a box, or how we capture human expertise in code.
At its very core, what we are talking about here is something called an expert system. By definition, this is simply a computer program designed to mimic the expertise and knowledge of a human expert in a specific field. Now, I really want to stress that word mimic here. This is super important. This isn't some independent, free-thinking AI that's just dreaming up brand new ideas. Now, it's fundamentally a highly structured computer program that is perfectly mirroring the accumulated knowledge of a flesh and blood specialist.
Honestly, you can think of it as essentially hooking up a human expert directly into a server rack. The whole goal is to take a person, the one holding the clipboard with all the answers, extract their internal rules for making decisions, and essentially embed them right into the hardware. This way, the system can answer questions and solve those really complex problems at lightning speed.
And because of that incredible speed and specialized knowledge, the real-world versatility of these systems is just massive. We use them for medical diagnosis to help doctors identify illnesses based on a list of symptoms. But they're also used deep underground for oil and mineral prospecting to predict exactly where valuable resources might be hiding. They find faults in car engines. They play incredibly high-level strategy games like chess. They aid in complex financial planning for taxes and investments. And they even calculate route scheduling to find the absolute most efficient paths for thousands of delivery vehicles. It's really everywhere.
Moving right along to section 2, anatomy of a decision. Let's open up the casing and see how it works.
Okay, so before we look at how all this connects, let's just break down the 5 core components of any expert system so it doesn't feel overwhelming. First, you have the user interface. That's simply where you type in your queries. Next, there's an explanation system to tell you exactly why a certain answer was given. Then, you have the inference engine, which acts as the central processor of the whole operation. And finally, you have the storage area, which is actually split into 2 distinct parts: the knowledge base, which holds the raw facts, and the rules base, which contains all the logic.
Now, what's really fascinating here is how these different pieces actually talk to each other. The inference engine sits right smack in the middle. It acts as the actual brain, or the main processing element, bridging the interface to the storage area. So when you input a query through the user interface, which is usually done just by answering a series of yes or no questions, that query goes straight to the inference engine. The engine then acts kind of like a superpowered search tool, or maybe like a very literal librarian. It applies the inference rules from the rules base against the gathered facts in the knowledge base to find a perfect match. Once it does, it sends that conclusion back out to you, while the explanation system steps in to lay out the specific criteria it used to get there. Make sense?
Which brings us to section 3. The logic funnel, or how the machine actually thinks.
To really grasp this, we have to realize that all of this fluid, nuanced human expertise, it first has to be flattened out into rigid, structured data tables. Take this matrix of a dog, a whale, and a duck, for example. The human expert has defined their distinct traits across 5 different attributes. So the system itself doesn't conceptually know what a whale is, not the way you or I do. It just has a digital record stating that a whale is a mammal, it lives in water, it makes sonic sounds, it has skin, it swims, and it has absolutely no legs. It organizes these facts purely as actionable data points.
But here's the thing. A static table of facts just isn't enough on its own to make a decision. And that is exactly where the rules base comes in.
The engine relies on a really strict chain of logic gates to process that knowledge base. We're talking about precise if this, then that statements. These statements serve as the literal bridges connecting those raw facts to final conclusions. Honestly, it's the closest thing the machine actually has to reasoning.
So the absolutely crucial takeaway here is that the machine doesn't actually think at all. It simply passes your queries through a funnel of these if-then rules. Let's say your query is to identify an unknown animal. The system runs Rule 1, if mammal equals yes. Boom, the duck is instantly eliminated. Then it runs Rule 2, and lives in water equals yes. Well, now the dog is eliminated. Finally, Rule 3, and has any legs equals no. It systematically narrows down the truth until only one possible conclusion remains. It is a whale. And there you have it. That is the logic funnel in action.
Now let's ground this logic funnel in a much more serious reality, like medical diagnosis. Imagine a patient sitting down and answering multiple choice or yes or no questions about their symptoms. That's the input. The inference engine compares those very specific symptoms to a vast medical knowledge base using that if-then rules base we just talked about. Then, instead of just spitting out a binary yes or no, the output maps to a probability. It might tell the doctor there's an 85% chance of the flu, while also suggesting some specific remedies or medical treatments as an action plan. It's the exact same funneling process as the whale example, just with much, much higher stakes.
Moving right along to Section 4, building the machine, taking this from the human mind into digital code.
Building one of these expert systems is a highly detailed, 6-step sequential process. Step 1 is gathering the information. Literally sitting down, interviewing human experts, and poring over textbooks or research papers. Step 2 is populating the knowledge base, meticulously entering all those structured facts into the repository. Step 3 is creating the rules base, which means programming those precise if-then logic loops we just covered. Step 4 is setting up the inference engine to seamlessly handle all of that logic. Step 5 is developing the user interface so the end user can actually interact with it. And finally, Step 6, which is arguably the most vital step of all, is full testing. You absolutely have to run the system through its paces with known outcomes to verify it reaches the 100% correct conclusions long before deploying it out there in the real world.
And that brings us to our final section, Section 5, the reality check, power versus cost.
Look, the advantages here are pretty undeniable. You get an exceptionally high level of expertise and accuracy, with incredibly fast response times compared to a human. They can endlessly store vast amounts of facts, and the results are consistent, completely unbiased, and they can even map the probability of correctness for you. However, the disadvantages are pretty steep. The setup and maintenance costs are exceptionally high, and users actually require considerable training to even operate the system correctly. Furthermore, they give completely cold responses that lack human empathy, which, as you can imagine, is a really tough barrier in sensitive situations like healthcare.
But beyond just the financial costs, there's a really critical hidden danger we need to highlight. An expert system is completely 100% bound by the quality of the information entered into it by the human programmers. Basically, it is only as good as its data. It becomes actively dangerous if users operate under the assumption that the machine is infallible and just never makes mistakes. A bad rule programmed during the building phase? That literally translates to a bad diagnosis in real life.
Which really leads us to pull back the curtain entirely on this technology. Ultimately, these machines are artificially structured, not artificially intelligent. The chaotic, brilliant tangle of human knowledge goes in the top of the funnel, and perfectly orderly data comes out the bottom. But the machine itself isn't generating new ideas. It doesn't replace human expertise at all. It simply digitizes it, immortalizes it, and scales it up for instant access.
I want to leave you with this final thought to chew on. An expert system does not think. It acts as a perfect, untiring, high-speed funnel for human knowledge. As we constantly continue to push the boundaries of technology, it really begs the question, can any machine ever truly replace the deep intuition and empathy of a human expert? Or will they always just remain highly efficient funnels for the brilliance we program into them? Thanks so much for joining me on this explainer, and remember to keep questioning what's really inside the glass box.